Hello and welcome to the new topic of operating system, that is memory management. So in this particular topic, we are going to learn about how the main memory will be managed by the operating system. What are the different criteria there, and what are the different concepts related to memory management. So the first, let's go to the basics of memory. So if we have the memory means it is a main memory. So what are the different criteria which is important? So the first criteria here that is important is the size of the memory. So what is our requirement? Our requirement is that we should have the increased size memory. So if we'll talk about main memory, why main memory is important? So if we'll talk about main memory, why main memory is important? So the thing is that as we know the architecture of the computer, that whatever program we have to execute, that should be there in the main memory. And you also know the ratio of the space or of the capacity of the main memory and the secondary memory is very different. So if in the system, in your laptop or in your desktop, let's say we have the secondary memory size of 1 terabyte. So generally we have the main memory of, let's say, 4 to 8 GB of memory, or maybe the 16 GB of memory. So you see the difference between these two are very high. It is around 250 times. So to manage these type of memory, which is very less in compared to the secondary memory, as well as we need to upload those programs which we want to use in the main memory. So that's why the management of main memory is important. So if we'll talk about the criteria with the main memory, so what we required all the time, we required that the size should be more, right? Size of the, or the capacity of the main memory should be more. The access time, what about the access time? So we required that the access time should be less, right? So whatever program or whatever data we required, that should be there in the main memory, and we can access that particular data or the program as quick as possible. And the third thing that we required is per cost unit. So per cost unit we want low. We want that the cost is should also low. But to get all those things possible, uh, it is not in the reality. In the reality, when we want to increase the size, the per cost unit will be increased, as well as with the increased size memory, the access time also will be increased, because to search those data, to access those data, it will take time. If we have the shorter size memory, the access time will be less, it is okay, as well as the per unit cost will be less, but the size will be less, right? So to meet all the three requirement, it is not at all possible, right? So if we want to understand the memory how it is working, so we have the simple concept that how the hierarchy of the memory is. So we have the secondary memory. Secondary memory is attached with the main memory, and then we have the cache memory, and then we have CPU and the CPU registers. So it says that the program must be brought from the disk into the main memory and placed within the process for it to be run. So whenever we want to run any program, that should be there in the main memory. That is uh, the architecture that if we are following. Then main memory and register are only storage that CPU can access directly. So here, if you'll see, here I have placed the cache memory. You just ignore the cache memory once. So what will happen is the CPU can directly access the cache, the main memory, as well as CPU has registers, which is in the form of cache. We have L1 cache, L2 cache, L3 cache. We talked about it in our previous classes. So we'll not talk about cache memory, and as well as cache memory is the interest in the computer organization subject, in which we learn many things related to the cache memory. But in this particular topic, we are focusing on the main memory. So assume that the register means the CPU cache or the register as well as the main memory can be accessed by the CPU directly. Register can access in one CPU cycle. Main memory can take many CPU cycles. The cache sits between main memory and the CPU register that is there in this particular diagram, as you can see. Protection of the memory required to ensure correct operation. So protection of the memory means how well we are fetching the data, that should be there. So protection should be there related to the memory retrieve, the data retrieval from the memory. Memory unit only see a stream of address plus read request. So in the memory unit, we have the stream of addresses either with the read request, or we have the address plus data with the write request. So we can read the data, we can write the data. If you want to read the data, we should have the address. If we want to write the data, we should also have the address as well as the data that we want to write on it. So if we'll talk about this hierarchy, we know that the CPU is generating the logical address, and this logical address should be converted in such a way so that it will convert into the physical address. Physical address is the address which is there in the main memory. Second thing, whatever data or whatever instruction we required, we have to fetch from the secondary memory. So from the secondary memory, the data will be fetched here. And whenever we doesn't require the data, we'll fetch back that particular data into the secondary memory. That process is called swapping. So what is the requirement of the main memory? So what happen is, let's say we have an instruction, number of instruction, let's say instruction 1, instruction 2. Let's say we have instruction 100, instruction 101, and we have, let's say, instruction 300. So we have these instruction available for related to a program. So let's say my program is running instruction 100. Now, what is the maximum chance that the next instruction will be called? So there is a maximum chance that the next instruction will be called. So this instruction, which is a next instruction, means 100 instruction I am executing. Definitely I have to have the next instruction with that particular program. So that thing, that particular concept is called locality of reference. Means we know that if some instruction is executing, so definitely the CPU will require the next instruction. So the next instruction means instruction 101 should be there in the main memory, and nearby instruction should be there in the main memory. That concept is called locality of reference. Locality of reference, with the help of the concept of locality of reference, we can predict those instructions which are required by the CPU in the future, and we can put it here in the main memory so that the access time should be reduced. Okay. So we used to keep those data which are required by the CPU, and we predicted using the locality of reference concept, and so that the access time will be reduced. So let's say if the CPU is requiring one data, so definitely let's say the hit ratio or the hit percentage will be the 90%. Means the 90% of the time whatever CPU is requiring will be there in the main memory. Let's say the access time of main memory is, let's say, 10 millisecond, and the access time of secondary memory will be 100 millisecond, because the the memory size is more, right? So definitely to access those data, it required more number of more time. So let's say the hit ratio is 90%, means 90% of the time, whatever data I required will be there in the main memory, and 10% of the time, the data is not there in the main memory. So we have to fetch the data from the secondary memory to the main memory, right? So for the access time for any data should be calculated as, so 90% of the time I am getting the data into the main memory, and the access time of the main memory is 10 millisecond, plus 10% of the time means zero point 0.1 I am checking into the main memory, plus and I'm not getting it. So I'll go to the secondary memory, and here we required 100 millisecond of the time. So for that, if you can consider here, we have, we'll get 9 millisecond, means here the access time is the 9 millisecond, and here the access time will be, let's say, it is 11 milliseconds. So total the access time will be 20 milliseconds. So you can see that 1% of 10% of the time I am accessing the secondary memory, and it is taking us a lot of time, and 90% of the time I am accessing the main memory, and it is taking very less number of time. So in that way we calculate the access time, and what is our requirement? Our requirement is access time should be less. So the size, access time, and the per unit cost. In that criteria, we are looking for that how we can make our system more efficient. Okay, so that is our objective to fulfill. Now in this particular topic, we are going to understand that how the data will be stored, how we can fetch the data from the main memory as well as from the secondary memory, what are the different criteria, what are the different methods to do that. All those things we'll see one by one.